Hello again. So, now the question is find the area of a regular octagon A, B, C, D, E, F, G, H with a side length of 4. So, let's actually draw this octagon out. Octo meaning 8, we know there's 8 sides. And since it's regular, all the side lengths have to be the same. So, let's try to draw the diagram as accurately as we can. And it's going to take a little while just because it's not the easiest thing to draw. A little bit more narrow. There we go. Alright, almost there, and it's kind of really skewed looking, but that's fine for the purposes of our problem. So let's just continue. Continue, and if I did it perfectly, it would connect like that. Alright, so a little misshapen, unfortunately, but still it's sufficient. 8 sides, 1, 2, 3, 4, 5, 6, 7, 8, each with a length of 4. Whoops. Okay. Now, what can I do from here? Well, we can try to break this down into simple shapes. Let's start by finding some of the interior angles. So we take 180 times the number of sides, 8, minus 2, over the number of sides, 8. That becomes, well, this is 6, and 6 over 8 divides evenly to become 3 over 4. And let's try to reduce this down even further. So 4, 180 divided by 4 is, that would be 90 over 2, which would become 45 degrees, multiplied by 3. Now that would be 120 plus 15, which would be 135. So that is a strange angle to work with, but so it doesn't seem like we could make any decent triangles out of this problem. So another shape we could possibly use is that of a square. Now, how could we make a square out of this? Well, if we connect the sort of missing pieces of the square like this, we'll get a nice diagram that we can work with. A lot of the time we take complex shapes and make it smaller into simpler shapes, but we can also expand complex shapes and it will still get us a simpler shape. Now, what can we do from here? Well, we have that this is a right angle, and this entire angle right here is 135 degrees. We know that the side length of the hypotenuse is 4, and it's going to be the same in each of the 4 little triangles with the dashed lines. So, how can I find what I'm looking for? Well, let's find out what this angle is. This angle has to be 180 minus 135. Since they're on a straight line, they must be supplementary. So 180 minus 130 is 50, minus 5 is 45 degrees. Which means that this is also 45 degrees, since this is a 90-degree angle. Which means we have a 45, 45, 90 triangle. Which means that this side is the length of the smaller sides divided by the square root of 2. So we have 4 divided by the square root of 2, which, with our simplification process, we multiply by the square root of 2 over square root of 2, and we get 4 root 2 over 2, which eventually 4 over 2 cancels out into just 2. So we have 2 times the square root of 2. Now, we can start filling in some of our missing spaces. So we have 2 root 2 on each of the side lengths. And I know in my diagram, it doesn't look like these measures are the same, but that's just because I didn't draw a perfect diagram. So, don't mind that. 2 root 2 and 2 root 2. Now, we also know that all the regular side lengths of the octagon is 4. Now, how can I approach the problem from here? Well, since we have a square, since all the sides are the same, and there's right angles on all these edges here, or on the vertices, I should say, we can find the area of the square. So, the area of the square is the length of the side, which is 4, plus 2 root 2 plus 2 root 2, which becomes 4 root 2, squared. Now, simplifying this a little bit further, we can square this binomial, and we will get, well, 4 squared is 16. Then we have 4 times 4 square root of 2, which is 16 square root of 2, plus 16 square root of 2, plus 4 root 2 squared is 16 times 2, which is 32. Just multiplying that out, it's just, you would have to write it like this. To kind of see what I'm doing. Hopefully we remember this from Algebra 1, but if you don't, that's okay. So, simplifying this even further, well, we have 16 root 2 plus 16 root 2 is 32 root 2. And 16 plus 32, well, that's 48. So we have 48 plus 32 root 2. Now, that's fine, but that's not the area we want. We want the area of the octagon. And we found the area of the square, which is too big. Well, if I find the area of each triangle and subtract it with the area of the square, I must be left with the area of the octagon. Because it would be like taking the pieces back out. So, let's find the area of the triangle. So, we have 1/2 base times height, and our base and height are the same, 2 root 2. Now, 1/2 and 2 cancels out here. Square root of 2 times square root of 2 becomes regular 2, and we have 2 times 2, which is 4. So, taking our two areas, we also have to take this area and multiply it by 4, because there's 4 triangles in our octagon. So 4 times 4 ends up just being 16. Times 4. Now, to find finally the area of the octagon, area of O, we just take the area of the square, so 48 plus 32 root 2, and subtract the area of each triangle, which amounts to 16. So our area of our octagon ends up being, well, 48 minus 16 is 32. So you have that it's 32 plus 32 root 2. Now the math is a little bit messier on this problem, but the process is always the same. Try to think about how we can simplify stuff, make shapes that we know how to work with to solve each problem.